Hi, so welcome to my latest submission for a CloudSpoke challenge, which is to add some enhancements to a previous challenge I worked on, which is building a generic XML response parser. So let's go into one of these object maps that I've created, and the main change that I've made to the object map is to add a new field called create attributes map. And what this does is, so typically in my previous submission, as you can see, these object attribute maps, these would be mapped onto the order class directly as a property. So if I just bring up an example, go to order, so it would be mapping it to one of these values. Now, what I was asked to do for this challenge was essentially, rather than adding them directly as attributes in the class, was to add each of them to an attributes map, basically so that the attributes could be iterated over in a Visual Force page to remove the need to add a field corresponding to each attribute listed on the class. So to give an example of that, go back to the map, what we'd be expecting to see within this attributes sort of map is expiry year, built year, built name, grand total, order number, credit card type, and expiry month. Take you to the page, which just kind of gives you a quick demo of how the functionality would work. So at this point I'm really only showing the order level attributes, but as you can see, I've got a repeats tag in the Visual Force page, and all it's doing is basically, like I said, iterating over the attributes map as opposed to calling out each property of that class and putting it onto the page. Also added target data type onto the object attribute map. So another part of this challenge was to investigate the potential for adding these to the attributes map, but when adding them with their sort of native primitive types. So rather than treating everything as a string, it was to investigate the possibility of adding them as, say, any primitive type really, so integer, decimal, date, time, etc. There are a number of challenges with that, which I'll go into later, but essentially for what I'm demoing right now, I am casting everything onto string, so that sort of target data type is being ignored. The other thing to mention with this create attributes map, it's obviously a flag, so if you were to uncheck it, then it doesn't map each of these attributes into the attributes map. It adds them directly as properties in the class. So you can choose which approach you use, and for each child object map, you equally on each of those you can choose also. Now, also something that came up with my previous submission is there are issues with mapping child object maps, so having essentially multiple entries under the same object map. So in my previous submission I had order line item, but when you added another child object map, I believe it threw an error. So I've now fixed that bug, and in this sort of example that I'm showing, you can see that there's another child object map called address, and equally if you were to go under the line item, there's another one called part. So in order to make the sort of transformation from the source document to the target object, I use techniques similar to last time that I've enhanced slightly. So what it does first, I'll just go to developer console, document mapping utilities, is it loads all of the object maps into a transformations map. So basically that's just a map of every single object map and object attribute map that exists in the object map hierarchy. It then proceeds with this method called transform. So it passes in the transformations, the source document. It has a target document that the result is being written to. So if we move to that method, it's at the bottom here. Yeah. So it comes into this method, transform. Searches through the transformations map to determine if the current path of the source document is present. If it finds a transformation, then essentially it creates a new target node in the target document, and then basically does a recursive call on itself and basically passes in the new target node that it's created. So for instance, if it's just created an order, it passes in the order node to the recursion, so that next time, say when it finds a order line, the order line is added to the order as opposed to adding it to the root of the target document. I've also made a couple of changes with regards to how it creates the target document. So if you the target document is output as raw XML, I'll show you the sort of thing that it's outputting. So it looks a lot more natural than it did in the last submission. So in the last submission, I kind of had like M-order at the top. I then had like a container element, which would be something like a map, that would then contain the line items. I've got rid of that completely now, so that the sort of target document more accurately reflects what the target object looks like. You can see it passes a few attributes under each element, so data type, so this is how I was basically defining when I transform to a JSON what the data type should be. We've still got a case of so when we hit a sort of child complex type such as line items, basically defines the collection type. If the collection type is map, then it also defines the key. So this is an example of basically what we end up with after doing the transform method. So the next stage is obviously to convert this XML document into a JSON. So if we get back to class, document mapping utilities, see this method called XML node to JSON. Again, it's a recursive call, but basically it operates over that XML document and converts it into the JSON representation of the object. So let's put a demo of that. So if I execute the code, move on to it, debug. So it might be quite hard to see, but essentially what you can see is that here, for example, the attributes are being added into this attributes map as opposed to being added as properties on the order directly. So what my bit of anonymous script there did is essentially return the JSON string from executing that object map, casts the JSON string onto a test order, and then reserializes it so that you can kind of see the before and after JSON string. Close that. I hate it when it bugs out like this. Annoying. We shall open that up again. we look at the before and after, so the before shows the attributes here. Obviously it hasn't bothered mapping any properties at the order level, but when we come back, so essentially we've deserialized the JSON string back into the object and then reserialized it, you can kind of see that the actual direct attributes of the order are set to null. And if you scroll right to the end of that message, you can see the attributes come out near the end somewhere. So there's an example, for instance, for an address set of attributes. Somewhere in here will be the order ones, but it's kind of hard to read when it's like this. But as I said, this kind of shows that as opposed to mapping it onto the properties, it's mapping it into the attributes map, and thus fulfilling the challenge of being able to write it out using these repeat elements. There was also a second part to the challenge, which was investigating the possibility of writing to an attributes map where where you could map any type of primitive element. So to give you an example of that, so say if I were to order here, rather than being of string, it would be of string object. I had fairly limited success with that, so if I open up the class, so I created a new class called object map. So whereas the previous example I showed you was basically a utility class which is of a static type, never needed to be instantiated. The challenge I came up with is that when you deserialize a JSON string, it doesn't allow you to cast onto the string object map. Basically objects not supported in a deserialization. So in order to get around that, I created a instance class object map that basically loads the transformations. So as you can see here, it gets the transformations, transforms the source to the target document, but that's where it leaves it. So essentially this class inside it has this target document, which is the representation that I showed you earlier of the transformed source document. You can then obviously I've added a method on here which is called getJSONString, which basically pulls out the target document. So to give an example of that, if I open up the test class for this, so we instantiate the object map, deserialize it into the order, but what this object mapper class doesn't do is it doesn't map the attributes because it can't cast those onto the attributes map of type string object. So the way I've kind of got around that is by storing the internal target document state in that class. I've then written another method called getAttributes, which basically returns a map of type string objects for the given element. So in this case I say an order, and if I go back to the object map, we have this method here called getAttributes. Basically appends result on, because result is always the root node of the target document, but it's in the additional path, so in this case morder, and then it basically traverses the target document until it finds the node with that path, when it finds that node, so in the example I just gave you, so it comes down to M order, it then converts each of the child elements that are of a primitive type, so the ones here that are data types, say integer, string, decimal, etc. It adds them to the attribute map, and then that attribute map is returned attribute map is then added on to the order. So for instance here we see order.attributes equals object mapper get attributes M order. Obviously the downside of this is then you have to attach the attributes to every child object of order. So for instance I've only got one layer deep here, but you have to iterate across the line items, and then for each line item you then need to call this object mapper get attributes, pass in the path, and then it returns attributes for that. So obviously if you end up with quite a deep hierarchy, then essentially you can have a lot of nested for loops retrieving all the attributes. So this is kind of like the best solution that I could come up with for it. It's definitely not ideal. I can't really think of a better way to do it. So I think to be honest, if it's not super critical that we cast back to the intended primitive type, I think going just back to a map of string and iterating over that on the Visual Force page is probably the way to go. The code is obviously attached to my submission. If you have any questions, feel free to get in contact with me. If not, have fun with this. Hopefully it does what you need and should be a bit more robust than my last submission, where I believe, as I said, it was failing when adding multiple child object maps to the root object map. So for instance the example I showed here, I've added in quite a number of different child complex types to kind of demonstrate that it's now working as intended. As I said, any questions, fire them over. If you do find any more bugs, equally happy to fix them, so let me know, and hope you like the solution. Thanks a lot.